Hey, what's up guys? Net Viking here, and as promised, I'm gonna show you how to use ZTP Dynamic Provisioning. Well, sort of dynamic because I'd rather call it hybrid really, because there are some static elements in the picture as well. Now, before diving deep into our ZTP server, I'm going to talk a bit about my topology here. As you can see, I have a spine leaf topology and would like to achieve VXLAN routing using head-end replication as the VXLAN control plane, which basically means that we need to specify a flood list that includes the remote VTEP IPs, and using BGP as the underlay transport between the spine and leaf switches. Now every leaf pair is in a separate AS, as you can see, and the spines are in the same autonomous system, so they are IBGP neighbors. I'm using two VLANs, VLAN 200 and VLAN 300, which are mapped to these VNIs. And as for the high availability and redundancy, I'm using MLAG and virtual ARP. Uh, both are awesome Arista technologies. Now, in order to conserve some IP address space, I configured my VLANs with IP address virtual. This way I won't need the physical address on the interfaces, and I can use the same virtual IP on all the leaf nodes and all the same also the same virtual MAC. So basically I have an Anycast model. Otherwise, each leaf node will have a physical IP, which in large DCs would consume your IP space pretty fast. Like if you'd have 255 leaves, 254 leaves, then you would consume whole slash 24 just for the leaves, just for one VLAN. But in this case, we can use the virtual IP option and share it across all the leaves. Also note that when using the IP address virtual command, routing adjacency cannot be formed over the VLAN interface. A VTEP will forward any ARP responses destined to the virtual router MAC to all the remote VTEPs. This way, the other VTEPs that are hosting the same virtual IP will receive ARP responses regardless of the host's location. And also the ARP response synchronization between the MLAC peers is achieved by the VXLAN agent. So the virtual IP feature will only work with VXLAN. Now, to avoid all VTEPs replying to a broadcasted ARP request, we can configure secondary IP on the loopback interface, which is called the virtual VTEP, which allows the virtual MAC to sit behind a single virtual VTEP. And again, all VTEPs will have the same virtual VTEP IP. So all of the leaves will have the same secondary loopback IP. The best part is that in this scenario, and when using VXLAN, you don't have to advertise your tenant's network into BGP. You'll only have to advertise your two loopback IPs, and that's it. You'll have end-to-end connectivity between your servers. Now, in my case, I've used a switch as a server because the VPCs in UnitLab don't have two ports or multiple ports, so I cannot I cannot do a port channel. And also this way I don't have to use gobs and gobs of virtual PCs because I can set up VLANs on the switch and simulate more servers on one switch. So, and of course this this is import channel, and the switches are using mlag, as you can see. Actually, I have a more beautiful picture here, which I'm going to show you immediately, just to explain that as you've seen in my last video, we need a cloud thingy connection, because this way I'm connecting to my external ZTP server, which is outside of Unit Lab, but it's in the same network as the second uh, interface of my Unit Lab server. So actually, where's the pictures? You can add a picture like this, and if you edit here, you can add the mapping to your nodes. So if I click here, it will open my line switch. Alright, so let's get going to the ZTP part. So here's our ZTP server. Now, this scenario will be completely different than the other one, because in order to use ZTP Dynamic Provisioning, there are a couple of files we need to use, and all of them are somehow interconnected, which you will see. Actually, I just can talk about what we have here. So if you go to user/share/ZTP server, you'll see a couple of directories and files, which we'll use most of them. So let's talk a bit about actions. If you go into the actions directory, you'll see that there are a couple of actions which are pretty self-explanatory what they are doing. Like add config is just adds config. Copy file, you'll use this action to copy, for example, an EOS image or a script to your device. Install extension, install image, replace config, send email. These are all pretty self-explanatory, and if you're curious, you can just see what are they doing. And as you can see, they are all written in Python. And the good thing is that if you need other kind of actions other than the ones that are here listed, you can write your own in Python. Nothing stops you. Alright, so where are we using these actions? Good question. We have definition files, which are in the definitions folder. Now, I created a definition for each and every switch of mine, because all of them have a unique thing, like IP, BGP neighbors, etc. So let me show you my first leaves definition file, and you'll understand a bit better what's going on here. So a definition file is where you define your actions. Actions like adding config to the switch, or copying a file to the switch. And as you can see, I'm not sure if you're familiar, but this is a YAML file. Basically, all of the other files are YAML files, which, if you don't know, YAML is pretty much the same thing as a Python dictionary. Like it does the same thing. You have a key and a value. You see, like you have action, add config, and then you have attributes, and then you have to specify what templates are you using. Templates are the configuelets. It's like configulet in CVP if you have used CVP, but we'll get there soon. So the system template, which will do basic system config, is located here. So /user /share /ZTP server /file /templates and system.template. And it has a single variable in it, which is the hostname. And we are using the allocate plugin to allocate the host names. And you'll see that the host names file is another YAML file, which is basically like a database. It contains host names and the MAC addresses. So ZTP will know which host name, which switch would have to have which host name, because based on the MAC address, he will allocate the host names. You will see just in a couple of minutes. And then you can add a name to your action. You can even add stuff which you could see on the debugging window when you're doing ZTPS dash debug, and you will see like starting to add basic system config, and if it's successful it will say basic config added, and you can just write here anything you want. Then my second action is to add the management IP to the switches, to the switch. The third one is to add some users. Fourth one, here we are configuring MLAG, and as you can see in my MLAG template I have 3 variables: the IP address for the peer-link VLAN, the subnet for it, and the neighbors, the MLAG peer's IP address. After that I'm adding my varp configlet, which doesn't have any variables because it will be shared across the leaves, so it was pointless to do variables here. And then I have a leaf template, a layer 3 template for the leaf, which configures the IPs on the interfaces towards the spine and the loopback IPs. And lastly, I have the BGP template, which you can see I have a couple of variables like the autonomous system number, first neighbor's IP, first neighbor's AES, second neighbor's IP, second neighbor's AES, advertising the first the loopback's first IP and the secondary IP after that, and that's it. The other leaves have almost the same thing but different IPs and different variables, and my spine is a bit different, of course, because it's just a pure layer 3 spine. So it has the same system template, management IP, adding management IP, adding the login template, and adding the layer 3 spine template, which has a lot more interfaces than the others, and also a lot more neighbors. So that's the definition files. Now let's move on to the templates. Templates can be found here. Basically, this is where you are making your templates. But if you don't have a templates folder, then you can just create one with mkdir. So here I have the templates folder, and these are my templates. So let's see how my system template looks like. And as you can see, as I said, there's only one variable, which is the hostname, and basic stuff, configuring IP routing and defining management VRF and doing a silly banner. Um, Alright, and let's take a look at my MLAC template. You can see configuring the port channel for the peer link, the VLAN for the MLAC peer link, and you can see that I have the IP and the subnet as a variable and the peer in the MLAC config. So it's pretty much straightforward. It's everything how you would do normally. You just put a dollar and a naming convention for your IP or anything that you want to make a variable. You just put a dollar and a string after that, and after that in the definition file you just use a key value pair to define what it will be. Now you can also leave it up to the ZTP server to do like sort of a dynamic allocation, but in my case I haven't done that because I don't like my server to randomly allocate IPs to the switches. Alright. Um, what else was interesting here, which was bigger? Yeah, let me show you the VARP template. Basically, you can see my config here. So this is how we configure VARP. We use virtual MAC address, and then we'll use the IP address virtual. So these will be the gateways for the servers, which this config will be shared across all the leaves, as I said. And let's see my leaf free template. So here you can see I'm defining the two VLANs I'm using, adding the IP to Ethernet interfaces, configuring my interface toward the server, putting the port channel in MLAG, and defining the loopback IPs. And this is my VXLAN config, which is pretty straightforward. Um, what else? And we have the leaf BGP, which is very straightforward. You just have the neighbors, two neighbors, and advertising the two loopback IPs. That's it. And let's see how the layers free spine template looks like. So these are just configlets. Pretty straightforward. So now let's move on to our database files, which are called resources. So in resources, you'll have uh, your database basically, which you can create uh, simply by creating a file and adding it one by one, like this. So you have key value pairs because this is a YAML file. As I said, it's like a Python dictionary. You have a key and a value. So in this case, this IP address, this management IP address will go to this MAC. This for this. And when you have null, it means that the first switch that contacts ZTP will be allocated this IP. So if I were to leave all of these at null, it will function as a first come first served basis. But we don't want to do that because then we won't know which switch is which only after connecting to them. So it's better to add the system MAC, or you can use the serial number, which is probably uh, mm, it. I think both of them are a good way, but in VIOS you can only use the MAC address, so here it's easier to do this. So this is how the management IP file looks like, and there's the other one, host names, and here are my host names, and you can see that spine 1 is this MAC, spine 2 is this MAC, leaf 1 this. So you get the idea. Another another file that is very important, which basically the root of all the connections here, is the neighbor.db file, which looks like this. So basically the neighbor.db, what it does is you have patterns, and for example, you can put the definitions here. So for example, here you are connecting your definition with a node. So my spine 1 definition, in the definition file, there's no way to tell to which switch you have to add those configlets. You have to do it here in the neighbor.db file, and this is the way to do it. Like you have the definition key, and the value is spine1 def, which is the name of my if you remember the name of the spine1's definition. So these names have to match. These have to be the same as this one. And then you can specify to which node it goes, and based on the MAC, it will add the configs to the switch that has this MAC. Now you can do lots of interesting stuff here with the interfaces. Basically, you can do stuff like matching a pattern, which would be like, in my case, it means that you will have to add a config to the switch only when, I mean, in this case, we don't care about what interfaces I have connected to with what devices, but we could do something like match the pattern based on the spine 1 switch to be connected on Ethernet 1 to, let's say, leaf 1 on Ethernet 3, and you could just change that and add here Ethernet 1, add here the device like leaf, and then colon Ethernet 2 or Ethernet 3 or whatever you want. Or if, for example, you were to specify any colon none, it would mean that you will apply the config only when nothing is connected to any of your interfaces, if I remember correctly. Yeah, but you can check these things on the GitHub page of ZTP server, or there's a very good page which I will put it in the description. It's ZTP server .readthedocs.io, which has a couple of examples regarding this. So, oh yeah, and the plugins, which, as you saw, we are using the allocate plugin. uh, which is allocating the IP from my resource files. Um, and yeah, you can write your own plugins if you want. Uh, there's even a plugin, I think that, oh yeah, SQLite, that you can use to generate some uh, databases like the resource files. So I think that's all we need for now. Let's check our DHCP if it's configured correctly. DHCP-dcpd.conf. So let's see. Yeah. So basically what will happen at first when we reboot the switches is um, the switch will receive an IP from this range. So let's say it will receive .80, and after that it will try to download the bootstrap file, which the bootstrap file points to the neighbor DB, and neighbor DB points to the definition file. The definition points to the templates in the files directory and the resources, and it will add the configs to the switch. So our management IP will change as well. So the ACP is okay. Now let's go to the switches. I've already set up the SSH connections to the switches, but of course after bright erasing the startup config, all the connections will be lost, and we'll see it from the console. So let's just make sure that we don't have, sorry, forgot that the bash ls. Yeah, okay, so right erase startup config, and no, sorry, right erase. Alright, actually I think I've done this. Okay, we've done it. Okay, okay, fifth one. Okay, reload now. Now I'm going to reload the switches and come back in a jiffy. I could have used the multi-execution button, but I was too lazy. Reload. Reload. Okay, so that's 1, 2, 3, 4, 5, and 6. Okie dokie. So now all of the 6 switches are rebooting. So let's open these up. Okay. Leave 3. Leave 4. 5. And 6. And the switches started to boot. They are attempting to connect to the ZTP server. So let's fire up ZTP with the debug, and let's see the magic happen. So seems that the switches are downloading. Okay, spine 1 is good to go. Spine 2 He's not booted yet. Okay. Some of the guys already booted. Yeah. Leaf 3 is good to go. Leaf 4. See, yeah, he's good to go. Okay, not all of them have booted. Leaf 5. Okay, is now booting. Yeah, so this is the most annoying part, guys. I have an i7 and 32 gig, and even this is too slow. I don't even think that uh, maybe better CPUs you would have a better speed, but uh, not that much. So I'm going to stop a bit now, and we'll be back when they're back. And now we are good to go. All of the switches have booted. So let's check them. Spine 1, it's okay. Spine 2, okay. Leaf 1, okay. Leaf 2, Leaf 3, Leaf 4. So all of them are okay. My banner is a bit messed up because of the spacing, but if I log in, it should be okay. Yeah. Alright, so let's see if it's worked. Now, just before that, I had a bit of an issue earlier, so I had to change some things, and I'd like to show you because you might bump into this issue as well. I did it a couple of days ago, and it took me a couple of hours to figure out what to do. But yeah, as I said in my first video, when you see 400, HTTP 400, it means that something is wrong in your config. Well, in this case, I think it was more of a bug because of VIOS, and I noticed this that 5 out of 6 switches boot up pretty well, and the last one has some issues. And in my case, it said for Spine 2 that he couldn't match any patterns, so the definition match failed. And it said no node match no patterns in the neighbor DB, and it just said error 400. So what I did here is edited the neighbor DB file. Let me show you just a sec. I went to Spine 2, and as you can see, I deleted the interface pattern matching key value pairs, and now it didn't care if the interfaces are connected to any of the switches. I don't know why this happened, but I noticed that on the 5th switch it's always happening for me, at least. But yeah, I fixed it and ran ZTP again, and the switch is booted. So let's see if if the IPs and the configs are allocated correctly. So my SSH should be working now on every switch. So press R, press R, press R. And as you can see, all of my switches are up and running. So let's do some tests. Show IPBGP. Okay, I have ECMP paths towards the loopbacks, which is cool. Now let's test the servers. Actually, back to the picture because it's more beautiful. So now let's do the tests. I'm going to open up this server. And alright, so I have 10 200 200.1, and on the other side I have 10 200 202 and 30 30 22. Sorry about this. Actually, let's close these down a bit. Don't need this. This was the other one. Alright, so let's do simple pings. So ping in on the other side works. Let's do trace route. So basically for him it's like he would be in the same network, because basically he is in the same network, but we are using VXLAN to stretch across spine leaf topology. So let's do let's test the inter-VLAN routing. Actually it was 22, so it works. So everything is working as it's supposed to. We can take even a look at the config. So as you can see, everything was added. My AAA configlet, hostname, two usernames, my VRF management, interface IPs, management configlet, BGP config. Same on the other side. You can see we have the warp, configured VXLAN, MLAG, BGP and MLAG. MLAG is working. We have active connection. And as you can see, we have the same VMAC on all of our leaves. So it's the same here. And here as well. Now you can do packet captures and see how the packets look like, and after that you can just simply download. So if you issue like TCP, go into bash TCP dump minus and EVVI and the interface you want to capture it, and then minus W to write it to a file like dump to pcap. When you hit enter, it will start to capture the file, and when you control C, it will finish the capturing, and then you'll see here in your directory the file which I had leave for pcap. I did a capture earlier, which you can download and open with Wireshark, or you can just read it with TCP dump minus R leave for pcap. And you can see the VXLAN packets. So that's it, guys. I hope you enjoyed it. Hope it was informative. And until next time, see you.